Good afternoon, everyone. As the first speaker after lunch, I hope I can get your attention. So here is the outline I wanted to share with you in the afternoon in 20 minutes. The first, let's go through a brief review of a manufacturing paradigm shift in the past almost 240 years. And then there's a second part is related to the latest development along with the Industry 4.0, particularly through two examples that we did at KTH. One is remote monitoring and control. The second one is a human-robot collaboration. The last part talk about how the value can be created along the direction of Industry 5.0. Over the past, if you see is a horizontal axis on top of the bar. So here, this relatively is only part of an industrial revolution, a more modern time. In 1913, we entered into mass production. And this is particularly enabled by Ford Motor Company after they introduced a floating line. Parts, materials can be moving from station to station. Through interchangeable parts introduced to the production line, company can rapidly reduce the cost through a large number of similar product in larger quantity. That's the objective for this manufacturing paradigm. Around the 1960s, we entered into another manufacturing age, is lean manufacturing. And this, of course, use the latest operations management approach method. People can reduce the waste at the same time improve the quality of products. First go on around the 1980, mass customization was introduced because customer wanted to have own signature product with own preference. This is the way how computer technology can be used to combine the advantage of mass production to produce large quantity of product, but at the assembly stage, customer have the voice to configure them together. So you have your product. So that's a mass customization, increase the variety of different products. Later on, around 2000, reconfigurable manufacturing, we apply the latest scientific technology, try to address the issue of responsiveness. Whenever on the shop floor, there's some change, the production line, cell, and machine can take care of that requirement and respond in a rapid speed. More recently, of course, today we're talking about sustainable manufacturing. Consider more global aim with a limited resource on our planet. And the aim is sustainability. One thing you can observe here is this bubble is getting bigger and bigger. The problem is also getting complicated more and more. In order to address sustainability, we cannot forget all the other objectives. They need to be addressed, satisfied at the same time. How to do that? Over time, people use a different algorithm to increase efficiency, productivity, and that gradually will towards smart manufacturing. Smart manufacturing is not only today. It is a step by step, has been exercised by many generations of engineers in the past decades. Consider with the human history have 20 million years. Industrial revolution is very short. And this time, if we look at Industry 1.0, is around 18th century, late 18th century, and until today. It's very short, about 240 years old. This Industry 4.0, initially introduced by German researchers and formalized by German government, was the product from Germany. It offer us a number of different opportunities as summarized in this pie chart. The inner circle is the value drivers. The outside is Industry 4.0 levels. And inside you can see asset utilization, labor, inventory, quality, and so on and so forth. This can be addressed by different technologies. What I want to share with you is for the labor, to help labor or address the social sustainability in remote monitoring and control and human-robot collaboration. That's the two aspects I wanted to share with you. Similarly, in USA, there's another roadmap has been rolled out. This is called the National Network of Manufacturing Innovation, or in short, is NMI. The idea is relatively simple. The US government wanted to create regional hub or clusters in different cities from coast to coast. Each cluster may engage a number of different local universities, research institutes, and local companies. They work together, focus on common research topics, join force. That's one hub. If different hubs can collaborate with each other, that naturally forms a national network. This was the design for NMI. Based on this design, the first pilot institute called America Makes was established in August 2012 in Youngstown, Ohio. That's the first one. In January 15, 2014, another one was announced. This one was Power Electronics. And for the name of the institute is called Power America in North Carolina. Another two institutes were announced 1 month later. In February 2014, these two, the name, one is called LIFT, another one called DMDII, focus on lightweight metal manufacturing and digital manufacturing and design. So this picture shows the announcement in White House. Currently, there's a 16 research institute already established from coast to coast. You can see the location, geographical location of the different institutes. And currently, the new name is called Manufacturing USA. If you see this logo, it represents the same thing, National Network of Manufacturing Innovation. Initially, the idea is to establish 15 institutes, but over 10 years period, established 45. Now more than almost 20 years has passed and only 16 institutes has been established. So there's a delay or different things matters. It doesn't really realize the original goal. In other part of the world, there's a different roadmap. Some of them you already heard. Made in China 2025 is one of them. Factories of the future, especially in Europe, was very popular. I participated several of the program in FOF. And in Sweden, we have a Production 2030 initiative as well, funded by government, national government. Over the time, we heard different terminologies. Those are considered enabling technologies that we can use. Cloud manufacturing digital twin systems of CPS, cyber physical systems, industrial internet, Internet of Things, embedded systems. All those terminology or technologies, if we can apply them properly to manufacturing setting, we can call this a smart manufacturing. That's the design or the definition, how to define a smart manufacturing, otherwise it would be very lengthy. I wanted to use two examples as mentioned earlier. One is a remote monitoring and control. We can consider this scenario as a cyber physical system example or as a digital twin example. The essence is to use a digital model to monitor and control a real device. In this case, for example, a real robot. Of course, this need software design, need methodology, need communication. We can use a publish, subscribe design pattern to design this system, just like we subscribe to a magazine. Whenever there's a new issue came out, we receive them. Many of us subscribe to different magazines or journal issues. The same idea applied here. As the user, I'm a user one. I'm interested to control this robot, so I send a request to the application server. This request is further passed down to the device adapter and passed down to the right controller for this robot. At the same time, I leave a fingerprint to the publisher. Publisher knows what I need. Whenever there's a change in the robot, the joint angle, speed, force, vibration, and so on, those information collected will be pushed back through the publisher to the user. That's me. Other users will not receive this information. So that's the basic communication pipeline. The second one is a human-robot collaboration. Normally, we use a robot to replace us, to help us to do the labor-intensive jobs. That's in the past for automation. But now, we want to use a robot to assist us, not to replace us. In that sense, robot need to learn from experienced operators, like shown here. Use an AI learning algorithm. The robot initially doesn't have any knowledge, but over time will learn from scratch and getting better and better from human by retrieving patterns. So this is a typical scenario. One human and one robot work together. In this case, it's in a dynamic environment. Normally, we use a pre-generated control code to control robot, but in this case, we cannot use pre-generated control code because the robot need to be respond to humans' needs, requirement dynamically, adaptively. So the alternative approach to control robot or communicate with robot is to through alternative modalities. One is use voice, talk with a robot. The second one is to use gestures to communicate with a robot. You can define different type of gestures as long as the system can understand. But all those gestures or speech is defined by human being and is controlled by human brain. So there's another one to communicate with the robot is just to use the brain waves. I provided a talk earlier on this topic, brain robotics. That's another way. But use the brain is not to completely replace speaking or any other type of modality. It's a combination. At a certain time, we need to select them wisely. Talking about Industry 4.0 and 5.0, you can check this diagram here. That's a comparison between 4.0 and 5.0. 5.0, I guess I blocked the way. Oh, here. So we can, Industry 5.0 can help at the labor level. Normally, we talk about a human or machine, but in 5.0, it's a human with machine. The machine can be a computer, can be AI that we talk about as a machine with embedded intelligence for the human. At the system level, we are talking about cognitive human physical systems instead of purely cyber physical system. At the product service level, we focus more on individual personalized services and product. First, on the supply chain level, focus on responsive and distributed supply chain. In the past, normally we focus on data analytics and figure out how to do the supply chain management, pretty much driven by data. And to the end, if we use the Internet of Things or connected devices, different technologies, we can realize a much greater satisfaction for the customers. That the customer experience is most important. And this highlight human need to be in the center. So this is Industry 5.0. This report was issued by European Union, especially by European Commission in January 2021. This is one report. And let's consider Industry 4.0, 5.0 from a technical and value creation perspective. 4.0 consider is a number of different enabling technologies, putting them together across in the physical world and the virtual world. Especially we focus on the intersection here, human-machine interaction, digital twin, and simulation to bring the two parts of the worlds together to generate more application potential. In the Industry 5.0, the focus is more on the value generation, especially for industry. There's a number of enabling technology already there, but how to bring the technology one step further for industry to create a business that not only needed to address the sustainability issues, but also needed to have a governmental support to have a right policy from a government. And through that analysis, the essence for the Industry 5.0 focus on human centricity, resilience, and sustainability. Any company in the future needed to address these three needs, not alone, need to address all of them. Another related issue is Society 5.0. Society 5.0 was introduced by Japanese government in 2016, 5 years before Industry 5.0. The interesting thing here is they share the common element, which is human centricity. For industry, human needed to be in the center. For society in the future, human also needed to be in the center. Especially in Japan, there's a large population. Density of a population is very high. And the natural resources is limited, the land is small compared with other countries. And Japan wanted to survive in the future with a limited resource and aging population. How to do that? Their aim is, of course, to guarantee human has the quality life, and human high quality life full of comfort and vitality. This can be realized by providing necessary goods and services for individual people at the necessary level when needed. That's address the lean. In a sense, it's sustainable. In order to realize this aim, they use a super smart technology. It's by merge between the cyberspace with the physical space with the 5G, big data, artificial intelligence, and so on. So that's the three elements for the Society 5.0. Compared the Society 5.0 with Industry 5.0, they according to the same timeline, but with a different time span. Industry 5.0 is much shorter. It's started from Society 3.0, that's Industry 1.0 starting point. So if you're interested more, you can also check this reference here about more details regarding Society 5.0. What I really wanted to share with you is the next slide, is my personal perspective into the future. This is for your reference. You can also criticize it, but it's my personal view. I consider that in the future, humans need to be in the center of the world, in the industry and society. Otherwise, we give our life to AI, to robot, to machines. Maybe our life or next generation will be in danger. In order to do that, human has very limited strength in terms of our muscle strength. How to do that? We can rely on augmented robots. Augmented robots or wearable robots can help us pick up heavy goods repetitively, accurately, without any fatigue over time. Then we can compete with the robot. That's one thing, to engage, energize ourselves. At the same time, we also need some support, like a cognitive system, intelligent agent system, to advise us. We have some knowledge, but our perception is based on our observation, limited observation. We normally don't have a holistic perspective. We look at the surroundings, seeing is believing, then we make a decision. But if we have this cognitive system, it can help us to reach a global, holistic, optimal solution. That's another ability. Then we also can use a mixed reality like augmented reality or digital twin to support us. Humans rely on the 5 senses, direct senses, to sense or perceive the world. This has a limitation. If we do not see it, we don't know. Use augmented reality. We can project the digital model directly in front of your eye. You can see something is invisible. Use a digital twin to predict into the future. We can see something is going to happen in the future. This visibility can help us. There's another support to us. And then it's a combine artificial intelligence with human intelligence together. This is also important. Not AI alone. Human intelligence needed to play a role there. I call this 4 enhanced human ability. By combining this together, we can then use our thoughts to directly control the robot. The robot will be our third arm or fourth arm. We can control multiple robots, use our thoughts. We consider just like move our hands. And the robot will help us to do the operation, assembly operation by assisting the human based on the real-time sensing data. And our knowledge is directly applied to human-centric assembly as an example. If we put different first letters of the words here, the aim is to use a human task. That's a future assembly. Well, human is still in the central control. This is one individual, but sometimes, most often, we need to work in a team. How to maximize the teamwork in a smart factory to make them sustainable and resilient is also our aim for the future factory. So that's what I want to share with you. Thank you.